One, two, 1, 2. Hello, everyone. I think we're about to start. It's time. If someone doesn't mind closing the door, maybe it'd be better. Thank you. Right. So my name is Mike. I'm working for a company called Bumble, and I'm going to be talking about clean architecture, the implementation we've done at Bumble. So before I dive into very specific code or examples, I'd like to talk to you about Bumble briefly. So we are a social networking app with ability to date, and we different from our competitors in a way that we allow women to make the first move. We've been on Android market for over 1 year old, and we've got impressive 2 million downloads. So how did we all start it? Well, we were lucky. We were lucky enough to have a clear canvas, start from scratch. Not many companies give you this opportunity unless you're a startup. We were lucky to have a clear canvas. And we also been given a set of features we needed to deliver between 3 to 4 months period. At that time, we also knew that we are a fast-growing team. We started with 1 developer originally, but now it's 3 Android devs, and we're constantly adding new features. So for us, the architecture and the process around it was very important from very early stage. We didn't want to spend too much time introducing to new developers how we do stuff, how we code, and so on. We needed to have a process. Every feature is written in a similar way, so it's easy to catch up and get the new guy basically working. So for us, architecture and process was everything. So how does it normally start when we get a clear start? Well, it's very easy. We are developers. We like to code, so we just go into the coding. And luckily, hopefully, that some of you already think about architecture at this stage, but some of us, unfortunately, don't. And if we've got a very simple app, let's say we've got an activity, we need to display some content, we just talk to the server, and there you go. App is working, everyone's happy. There is no problems at that time. However, the application is evolving. It's getting more and more features added. And therefore, our code gets more components, more services, global listeners, whatever we call them. And we keep on adding these dependencies arrows everywhere. So basically, the feature is all over the place. You just don't know where the business rules for the feature are. There is no single place. And obviously, we keep on adding more and more features. GCM kicks in, then we got some caching, and then we end up with an architecture like that, or lack of architecture, really. And we've got a new guy starting tomorrow. How are we going to explain him like how chat works? Well, it's going to be hard, right? Because you need to explain him every component we have and jump around them and explain him what is the business rule for the chat. It's going to be hard. So what we usually do, we escape to MVP, which is design pattern, which is all good. You are sorting out the presentation logic in one place, but model view presenter is talking about model, where model is everything. It's not the Pojo, model in MVP is everything else. So basically, you move the arrows just to the model, but you still got the same problem. Well, UI is all nice and tidy, but then what is the business rules? You know, how the feature works? How do we know the feature communicates with other features and so on? It's not very clear. So usually what happens is we just grow in the technical debt ourselves. And don't get me wrong, it's impossible to not have technical debt in your app. But you as an engineer, it's your job to keep it minimal, ideally linear. If it starts to grow exponentially, that's our project owner at Bumble, he's very happy. He's just going to go nuts. Every feature he gives you, he gives more and more time to estimate, to implement it. And without a good architecture, it's just really, really hard to keep the technical debt under the control. So Robert C. Martin said, a good architecture emphasizes the use case and decouples them from peripheral concerns. So what does it mean? It's like, okay, use case. Use case is where the business logic is, where the behavior of your app is explained, the rules. And the rest is just implementation. We don't care. And that's twisting everything around. I don't know how many of you have written a component like chat, database, messaging, or whatever around database. And then imagine replacing this SQLite database with a file system. If you've written the component around it, it's going to be really hard. And what clean architecture says, do not focus on tools. Do not focus on Android. Do not focus on databases, file systems. Don't focus on that. Get your business rules sorted first. Then you have to think about how to implement it later on. And if you need to, you just change it. So, what is clean architecture? Like I said, the guy from before the slide is a founder of clean architecture. And really, clean architecture is nothing else but a combination of various ideas, design patterns, and so on. I am not going into the details of every bullet point here. However, I recommend to have a read about them so you can actually understand clean architecture more. But there are a couple of things that I'd like to point out, which is like single responsibility principle, which is basically saying that your component, your module should just do one thing and only that thing. Onion architecture, where you got layers in your architecture of the app separated from each other, so you can replace them. But again, clean architecture is just a combination of all of them together, and it gives you a nice, it improves your visibility of the features, readability of your features, and understanding the business rules, where the implementation is just the detail. So, clean architecture. The key points of clean architecture, which is structure, use cases, models, dependencies, and testability. And this is what this talk is going to be about. I'm going to go through each of these bullet points into the greater detail on, later on. So let's start with the first one, structure. So it's very tricky, right? What the application is, not how it does it. Well, okay, let's try to visualize it. We've got these blueprints or design of this building. Well, looking at it, you probably can guess it's a church. You can see an altar, northern and south transept, some entrance, so you can get an idea it's a church. Well, at this moment, you don't care how it's built. You don't care if it's built of brick walls, glass, wood. You don't care. It's a building. That's a church. And that's what you need to try to get in your architecture. When someone gets into your when someone looks at your structure of application, they need to understand briefly what it is. So we thought we did it right at the beginning. At the very early stage, we thought like, yeah, structure is so easy. Well, let's try to create a couple packages and let's put features inside. So we had a boundary, presenter, and repository. Boundary in clean architecture is a door to your feature. So that's how you talk to the feature. Presenter is obviously MVP or whatever other presenters you can use, so it's UI. And repository is like server communication, caching, and so on. Well, it's all beautiful, right? You can see we've got the chat and the user. Yeah, but then if you add 50 more features, try to navigate that. It's pretty hard. You're trying to understand like why boundary is talking to that repository, and then you're navigating through so many packages. And that's what the structure is about. You need to get it into the state that when someone goes into your app, they can see the features. Oh, there is a chat and some users. Okay. And then if I open user, I can see, oh, there is some presentation, boundary model. So you kind of get an idea. Okay, these are the features. There are some implementation details there. And you know it's probably an app about chat and users. That's simple as that. It's not very hard. So the next key point of clean architecture was the use case. And this is probably the most crucial one because this is where you have to get your business logic. So it holds your business logic. However, it just doesn't care about implementation. It doesn't care about the tools you use. It doesn't care about UI you use. It's just business logic. So let's talk about example. User on the left wants to send a message to user on the right. Use case simple says, hey, send me the message. It doesn't care how. It doesn't care if user entered the message using text input field or keyboard or whatever. It doesn't care it's been sent via a presenter. It doesn't also care if it's going to get cached in the database or even sent to the server. The use case is simple, send me the message. So maybe that's going to help to visualize where we're getting. Use case to use case interaction. So these features you're defining, they can talk to each other. I wanted to use a Bumble example. However, many of you might not know Bumble, so I thought it'd be easier to start from scratch and create a really, really simple example. By the way, I've written an app, an example app. You can download it at the end of the slides. But it's a very simple, I would say, car app, where we've got the battery, lights, and engine. Use case, simple. User, turn the lights on. Well, okay, the job is done. User tries to turn the lights on. But the business logic says, also, when you turn the lights on, you have to start discharging the battery, right? So this is the business logic. When the battery goes flat, the lights need to turn off. So many of you might think, it's like, why is it not in presenter? Well, it's not presentation logic, it's the business logic. So we've been told there are some rules, and they need to be core rules, and we need to follow them. Let's say, what if the user wants to charge the battery? Well, it starts the engine, and then use case, engine use case can talk to the battery use case saying, look, you're charging now, and the lights, please turn yourself on. So this is about use cases, moving the business rules of your application to separate independent module. So the next thing is models. And not the models from MVP, simple modules. So ideally immutable. In Bumble, we try to keep them immutable. Well, we do keep them immutable. And they do not contain any logic. Either business or UI, they don't contain any logic. They're just simple modules. We also follow a law of Demeter, which I will explain next slide. We only hold data that's relevant to a given model. Our models never store data that are used somewhere else but this place. So let's try to visualize it. Model transformations. We've got a server, which gives us either JSON or Proto, we don't care. And we've got this feature, the feature that's been defined by business rules. We transform that JSON Proto model to the model that makes sense to application feature. It's only relevant to that application. Then what we can do again, from the application feature, which was a use case, for instance, the presentation has its own model, which only makes sense to the presentation. Okay, let's look at the example then. So law of Demeter says, a module should not know about the innards of object it manipulates. In other words, if we got a server, and we've got a model from the server, which is a user, there is a name, age, gender, failed logins, and photo count. Our application feature rewriting might not care about failed logins. Simply as that. So we strip it off in the transformation layer. So we say, now we only have name, gender, age, and photo count, but we don't have these failed logins. But additionally, we're trying to figure out ourselves if it's my user or not. So that's law of Demeter, where we strip the things we don't need. When we go to presentation, though, we might even strip more. So we remove even more fields, and we just put the model that is making sense to the presentation. So like MVP in this case. Why? Why we do all these transformations? Like, come on, this is just complicated. Why don't you just skip these fields and don't use them? Well, that means you could have used just server model and you propagate it through all your layers of application and just display it. Well, that's all good. What if you change the server endpoint tomorrow? Will you just rewrite all the models? No. You just write a one transformation class, which is the arrow, and then you convert it to the model. That's it. And you've got the, think of it as like your interface. You just transform to it, and you don't care where you're coming from. But sometimes your model might be very simple and it might not make sense for you to write all of this transformation. That's all fine. I mean, there's always a silver bullet. But if you got like complex models, think of it if it's not worth to chuck it out and create your own models so you can change the server endpoint or whatever anytime you want. Right, the next key point was dependencies. And this is where most of us actually fail. And we even did some mistakes. But let's try to think. Let's think of an example again. So we've got a UI. This user is entering the text. And he clicks send. So UI knows of presenter. Then presenter is UI's dependency, right? But presenter doesn't know about this UI implementation. It doesn't even know if it's Android or console, or it doesn't matter. So the message is being handled to presenter to be sent. Then presenter does the same to the use case. It knows of an instance of a use case, but use case doesn't know about presenter. So it says, hey, use case, send the message. I don't care how, I don't know what you're going to do, but just send the message. That's all good. So all dependencies going inwards. Think of them as independent libraries. If you take use cases out, you can compile them as a jar and just ship them up separately. They should not have any exterior dependencies to presenters. But you know what? To send a message, we need to somehow talk to the server from the use case. And this is where the gateways come in. So gateways in Clean architecture is the way for use cases to talk out. The interface that's defined in the use case is within the use case, so it's an external. It's for external usage. So use case doesn't know the implementation of the gateway, but your gateway implementation might be repository or server communication, that doesn't matter. So this is called inversion of control. And how do you do that? So imagine having a use case. It needs to have this gateway implementation. So you can either pass it to the use case via constructor, or you can just use a dependency injection. But the most important thing, it needs to be implemented outside. And use case doesn't need to know how it's implemented. The same for the server. Gateway doesn't need to know about server. So it depends how many layers you go. Usually gateway is very abstract, and it's got data sources or repository with the data sources, and the data sources itself that are very specific to the implementation. Let's say the data source can be database SQL implementation. But repository, which is a gateway implementation, does not need to know that. It just needs to have a common way to say, look, send a message, I don't care how. And this is the very, very important bit, because if you make your data source, which is at this layer, implementation of DB, that means tomorrow you can replace it with a file system, and you're not going to change any of the above layers, because it's just an implementation detail. You have to think of it completely opposite. Rather than building around database, you make it like a plugin. Like, you know, I want to use something, just send it, I don't care how. Or give me data, I don't care how. So this is again the same thing with just representing differently, the same diagram. UI depends on presenter, presenter depends on use case, and use case got gateway injected, gateway got server injected. So what we found out at Bumble, when we started to think layers a lot, we started to produce code, you've seen the structure, that was very, very around layers. And instead of what we said, like, come on, we're just writing features. So why don't we just think about features instead? Just we making a really decoupled business model, business logic, and then write a feature around it. Let's make it decoupled, but let's try not to think layers. Let's try to use single responsibility principle and decouple modules. So what we ended up with is this monster. We've got, I hope you can read it. This one is presentation, feature definition, Android UI, and repository. And feature definition is where your business logic relies. This is where only place where the business logic is, you know, like turning lights off and discharging battery and so on. You've got the boundary, which is your door to talk to the feature. If you want something from the feature, you say, hey, start sending message. It's via boundary. When the use case needs to talk to you, it's via callback or boundary out. Some of you might have heard of ports in and out, but that's how the use case talks back to outside world. And when it needs to talk to server or some other implementation, doesn't care which one, it uses a gateway. And please note also, we've got entities there. Entities are business objects of the application. Well, in other words, these are the models I mentioned before. However, I decided to call them entities here. First of all, entities is the name of clean architecture for models or for business objects. And I did not want to confuse anyone with MVP, because MVP talks about model view presenter, and we don't want I don't want you to think the model is from MVP is the same as this entity. So again, use case has a gateway, talks to the gateway, and doesn't care about implementation of the gateway. And in this case, it's a repository with some data sources. Yeah, that's implementation specific. So it could be messages repository, and data source 1 is database, data source 2 is file system, and 3 is memory cache. Doesn't matter. Then we've got presentation, which is standard MVP, nothing fancy, except the model view presenter in this way doesn't have any business logic. It's just so dumb. It's saying, look, when the battery is discharging, for instance, if it's at 70%, change the color of the text to yellow. That's presentation logic, not business. So keep it there. Business logic is separated. UI logic separated. And then we've got our lovely Android, which just implements Vue. So it has absolutely no knowledge. And you can replace Android in this case with console, whatever you want. So this is how we write features in Bumble. We have each of these components or modules separated out. And what does it give us? So let's look at this use case again, yeah? Or application feature. Feature definition, sorry, feature definition. So use case is in the center. That's our business logic. Also, it does not know about Android. There's no Android code there. It's pure Java for us. And what does it give us? Well, it's all testable and decoupled. So we run JUnit on it, and it's super quick. And we can mock all the dependencies very easily because they are interfaces. So we can test very, very easily business logic without any implementation details. The same comes to repository. Data sources, which is the lower bit, are replaceable. So the repositories, the whole repositories can be replaceable. Because our feature doesn't care where it talks to. As soon as you implement it, it's all good. Give me the data when I need it and send the data, or I give you the data, you do something with it. And in our case, repositories are also pure Java. Data sources might not be, because they might have some specific implementation details, that like SQLite or some file systems, whatever you use, just name it, Realm. So these can be very tool specific, and they should be, but they need to be replaceable. And again, it's all testable and decoupled. You can easily test your cache repository and mock the data sources and do some tricky logic, but it's all testable because it's all interfaces. Well, the presentation, well, I think you all know about MVP, so there's nothing new here. We do exactly the same, except we don't have any business logic here, because business logic is talking to the use cases. Sorry, the model is talking to use cases, which contains business logic. So here, you're just purely testing UI. And what's beautiful about it is, like, for us, MVP doesn't know about Android either. It's got the Vue interface. That means we can test UI logic without Android. So again, it's testable, decoupled, and we run JUnit on it. So it was really, really quick for us as well. The only thing that contains Android is obviously the Android UI, which implements the Vue. And as Uncle Bob said, or Robert C. Martin, this is a peripheral of concern. That means we can replace it whenever we want it. And obviously, it only knows about MVP, doesn't know about use cases, it doesn't know any implementation details. Right, the next thing, the last bit from structure was testability. I hope you've noticed that most of our components are pure Java. So we could easily run JUnits on them. We could mock the stuff we needed. We could have mocked the whole boundaries, callbacks, and so on to test MVP. We could test use cases and business logic without MVP, without repository implementation. So everything is really decoupled and testable. And again, Android is peripheral of concern. That means we can remove it. So this is where when you really, really want to test UI in terms of if the button has been shown, if the text is gone, well, then you can really use Android-specific test cases. But we decided we've tested presentation logic. Well, we can visually test quickly if the button appears or not. Well, it's up to you how deep you want to go with the testing. So what were our outcomes? Yeah, our code became very testable. We can test any component we want now. And at the beginning, we did actually go for Android test cases. And we quickly realized, it's like, why do we even use them? We don't have any dependencies. So we chopped the 2 minutes running time for Android tests to 15 seconds JUnit. Same job. Much, much quicker. And from very beginning, our architecture was changing slightly over a year and so. So we were always following single responsibility principle. And that allowed us to move classes around way easier. Even if we decided to change our architecture or change the structure and so on, it was way easier for us because everything was modularized. That's going to be it. I have the link to the app, example app. I didn't want to put any codes in my slides because I think it's better if you want it, just dive into the code, have a look at the business logic, how it's implementing this simple car app, and have a look at the presentation logic. Hopefully, you're going to get the flow, what we're trying to achieve here with Clean architecture. Dziękuję bardzo.